question number 40 CY 2013, and the question is uh, the decarbonylation reaction of cis CH3CO Mn13CO whole 4 yields three compounds X, Y, and Z, where X equals to CH3MnCO whole 5, Y equals to cis CH3Mn13CO whole 4, and Z equals to trans CH3Mn13CO whole 4. So we have to find out the molar ratio of the product, that is X is to Y is to Z in this reaction. There are four options given. Option A 1 is to 1 is to 1, option B 1 is to 2 is to 1, option C 1 is to 1 is to 2, and option D 2 is to 1 is to 1. So we have to find out the correct answer among these four options. Now coming to the question. So the given complex in this question is, okay, cis COCH3 Mn13CO whole 4, where the carbonyl incorporated with 13C and COCH3 group are cis to each other, and this is an Mn octahedral complex and kind of octahedral carbonyl complex. Now the reaction is decarbonylation. That is, one of the CO group will liberate and the uh, corresponding products will form. So there are three products is forming. First one is, this is X, then Y, this is Y, cis CH3Mn13CO whole 4, and finally this is the compound Z, trans CH3MnCO whole 4. So in the cis compound, that is Y, the 30 in the CO with 13C incorporated and the CH3 group are cis to each other, and the compound Z, where the CO having the 13C incorporated and the CH3 group are trans to each other. So these three products is forming by the decarbonylation of, so these three products are forming by the decarbonylation of this complex cis COCH3 Mn13CO whole 4. Now there are two processes of decarbonylation. What are the two processes? This is decarbonylation. First process is CO group elimination corresponding insertion of CH2 group. And the second process is simultaneous CH3 insertion and CO elimination. So two process. In one process, first the CO group, one of the CO will eliminate, and in the next step, CH3 will come in the place of CO and the compound will form. And another method is simultaneously CO insertion and simultaneously CH3 insertion and CO elimination will happen. Now, if we come to the first one, that is first CO elimination, then insertion of CH3 group. In that case, what will happen? We can starting from this compound, and let's see any one of the uh, CO of these five CO groups will eliminate, and what will happen? Okay, first this TVP complex will form. Here the total electron count is 16. Before it is 18. So the stability is decreased now, since a 16 electron complex of manganese are not very much stable with respect to its 18 electron complex. So here the chances are this CH3 group will come from the CuCH3 and attack manganese and will form our product. But you can see in the first reaction, that is the CO elimination, this is a reversible step. First CO will come, CO will eliminate, and the TUP compound will form. But since this is reversible, there is a chance that the CO again will come back and attack this compound to form the starting material. That is the reverse reaction. Uh, Thus, this process will not give our required three products, that is X, Y, and Z. So we will cancel out this first process, that is first CO elimination, then insertion of CH3 group. Now we will think about simultaneous CO insertion and CO elimination. For that, we will draw the compound again. Now this CH3 group can migrate from COCH to manganese, and any one of the CO group which are cis to this acyl group, that is this axial 13 CO, another axial CO, and this equatorial 2 CO groups. Uh, the CO which will be simultaneously eliminated have to be the cis CO group with respect to the acyl group. There is another CO group, that is the trans one, that this CO is very far away from this acyl group. Thus, this CH3 will not attack in that way that this trans CO group will eliminate. So we will think about only of this four cis CO group, two axial and two equatorial. Now, if you think that this axial CO that is having the 13C incorporated is eliminated, what will happen? So this is our compound X. Okay. Again, think that this trans CO is eliminated. If this is also a cis to this acyl group, what will happen? Now, here the carbonyl having 13C and the CH3 group is now trans to each other. So this is the compound Z. Okay, so we found the compounds X and Z. Now you have to found the compound Y. And here there are two equatorial CO group which is cis to this acyl group. So both of these CO group can be eliminated with the simultaneous insertion of CH3. Thus, two of this product, cis products will form. Okay, we put the 13C incorporated CO in the axial position. Let's say this is CH3, and in other This is the another CH3. So here this is one of the equatorial position, and this is another equatorial position. Both is occupied by the CH3, and the CO groups are eliminated from those respective position. So this is cis CH3 Mn 13CO CO whole 4 is both of this compound. So that is compound Y. And how many equivalent of this compound is forming? That is two equivalent. Thus X is forming one equivalent, Z is forming one equivalent, and Y two equivalent. So our X is to Y is to Z ratio is 1 is to 2 is to 1. So your answer is option B.
You can find the reference through the lecture on organometallic chemistry, migration and insertion reactions. That is lecture 9 by Professor Devabroto Maiti, Department of Chemistry, IIT Bombay. And this is the YouTube link of that said video. Thank you.